Okay. So right now we'll be doing two questions. We'll be doing 47 and 48. Anything past questions, what is it? 40? I'm pretty sure requires or uses all 8 rules. So you'll be using CD, simp, conjugation, and add, as well as the first 4, which were modus ponens, modus tollens, pure hypothetical syllogism, disjunctive syllogism. So keep that in mind. Okay. So because these are actually using all 4 and are actually more difficult, at least more difficult for me when I was first doing them, I'm going to take it a little slower, and I might just go over it a little bit more, just sound more redundant, just to make sure that even I don't mess up while doing this again. Okay. So we have 6 lines, and they start off with obviously giving us the conclusion. So that's B. So what we do now is we go back into the thing and we find B. We find B right here. Okay? So we try to get this B by itself, or this thing by itself. So here it is. Now, the way we get or prove this, because we need to prove how we got 6 by 5, we use the rule of where is it? Oh boy. Okay. We use simplification. Simplification is P and Q. You remove Q completely and you're left over with P. And that's what we're going to do here. B and D, we remove D and then we are left over with B. So 5 is 7. Okay, well now we have to prove line 5, which again tends to mean that you have to have explaining the other one and using the previous one. So the best way we can prove these 2 lines, or line 1, how to get it, is by dividing it or getting them both individually. Now the one that uses that is, we have to find one in the horseshoe and the one that divides it. So we look back at the rules and we use MP, PQ, and then we separate both of them. Now, something to make sure of, PQ doesn't always mean that like it's divided in this 2 ways. For right now, let's pretend that this was a horseshoe. This doesn't mean this is PQ, this is P, and then this is Q, and that this side is, let's pretend again, this is a horseshoe, this is P, and then this is Q. No, the entire thing as a whole, all of this is P. So parentheses to parentheses, this is all P, and then parentheses to parentheses, this is all Q. Again, just to make sure. So we go back to that, and then the way we write it is 1 and then 4. Because again, it tends to be that as we go down 5, 4, and then this one's going to be probably 3. Okay, and so when we use MP to divide it, we need to have A, negative A, V, G. Now we have that here, but the thing is, it's already in another thing. We need this individually. So we're going to have to write it here. Actually, I have to read percentage, or the parentheses. Okay. Okay. Just want to erase the parentheses because they're not really needed. So now that we have that, we have AG, we sort of have to, how do you say, prove it. So we can use how that we've used up line 1, 4, and 5. So 4, 5, what was it, 1? Yeah, so now we have 2 and 3. You can repeat, some of them will have to repeat. and sometimes you only have one per line, like 6 only has 5, but it tends to be you have to at least use all of them once. So here we need to use 3 and 2. Well, how can we use 3 and 2? Well, we see here that what is this? This is a DS. Ooh. Oh, right. Okay. So, looking at our rules and what we have on here, we can see that we haven't used C and we still haven't used 3. So one thing that we see here is that this is a V and that there's a negative C. So we go back into our rules to see anything that works with that. This is a horseshoe. This requires 2 sort of combination. This one has a horseshoe, but it has both negatives. And while number 4 already is a negative, that would make it a double negative. So we don't want that. And then what we do have is disjunctive syllogism, which is DS. It makes P negative, but Q remains the same. And that's what we have here. If we do that, we would get 3 and then 2 using, what was it, DS. And that way it proves all of them. Yeah, I think that's it. If you want to check it, what I used to do is, like, let's say I want to write this down and then use it. I could use C, V, then parentheses, A, V, then G. Since we know we're going to be separating it, this becomes a negative C, and then this just becomes a separate A, V, C, G. And clearly we have that in 4, so I guess you can say that's proven. And then we have that in line 2, and we can say that's also proven. So this is how I used to also check it. You don't have to do it, but you know, I guess it might help you. Alrighty, and now we'll be working on question 48. Alright, so we're giving the conclusion of negative G and C, and then here we wrote it at the final line. Okay, so an important thing to remember is in these spots, we can basically write whatever we want within reason. So we're going to have to create this answer, because trying to figure out something here using all the other methods to get this answer directly, we just can't. We do have a G and a C, but because this isn't sort of like the horseshoe way, we can't use the other method, which would be, which one was it? Like constructive dilemma, CD. We can't put it together. Or they're not even in the same line, so we can't use that. So one thing that we're going to use, which can work, is we're going to fill these in with just the answer themselves. So G, and then here we're going to put C, and we will be backing these up. So using that 5 and 4, 5 because it goes first, and then 4 because it follows, we use the conjunction rule, which basically means it just puts it together. There it is. P and Q combine with the and symbol. Now, you know, once we have these, we have to prove that these sort of can actually even be created in here. So I'm going to do the work on this side right here. So let's start by proving number 5, negative G. Well, we have a G here. So what we're going to do is we're going to separate it to here. I have a, sorry. Okay. So we need a negative g, and we look back to any of the problems or any of the equations and where we can have a negative p. Well, you see here that this one has a p, a negative p. And you might think, oh, well, that's the perfect one. But we also see that line 1 also has a negative version of what we have here. So rather than using ds, we're going to be using, you couldn't even use that because it has a v. My bad. But still, we want to use mt because it creates both negatives. So using mt, modus tollens, we get negative g and then negative a horseshoe b. And can that be proven? Well, yeah, we have it on 5. We wrote it ourselves, and then we have it in line 1. So yeah. So the way we would write it as we got it correct would be 3, which is the main line. So that's why it goes first, because that's where we got the equation from. And then 1, because that is the other outcome that we got. We got negative g, but we also got negative a horseshoes b. And we write mt. Okay, well, we have 1, 3, 5, and 4. Okay, now we just really have 2. So we have C. Well, we have C here. So let's see. We can write it down over here. Parentheses, A horseshoes B, and then V, C. So we just go and look at which one has a V. This one has a V, but it separates it only into the P. Which is probably what we don't want. And then, where is that? This one has a V, P and Q, and it makes P negative. That could work. It separates them, and it makes it a negative. Now, here's the thing. Doing that, this is our P, and this is our Q. This becomes, again, negative, parentheses, A, horseshoes B, and then C. So, does this prove it? Yes. We have a C, the one that we created here in line 4. And then you can see that we have this again. Now, it doesn't mean that it's wrong, because it just automatically means, well, we have it here, so that means it's just proven again. So this is one of those times when I said that there are going to be times when you might only have one answer or one supporting number, or that numbers actually do what is it? Share the common. So right there. And yeah, that's how you do it. These are more harder, or much more difficult. But you can sort of use the answer sheet and kind of like build back on that. And you know, don't be afraid to experiment, since you basically get to choose what you write in. All right. If you have any questions, I guess ask me in the group me, or maybe in the comments. Goodbye.